Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the initiation phase of the transcription mechanism in case of eukaryotes. Is it clear? So what exactly happens during the initiation phase of the transcription mechanism in case of eukaryotes? So likewise the prokaryotic transcription mechanism, in order to initiate the specific mechanism or the specific process, the transcription mechanism or the transcription process, it takes the advantage of a concerned site which is a part of the double-stranded genomic sequence, and that specific concerned site which is a part of the double-stranded genomic sequence, it is nothing but what? Promoter. So by taking the advantage of the promoter, the transcription mechanism or the transcription process, it is successfully initiated in case of eukaryotes. So if we consider the specific eukaryotic promoter, the specific eukaryotic promoter, basically it consists of two different components. So what are the two different components here? The two different components of the eukaryotic promoter, it include core promoter. Is it clear? Core promoter, and the other component, it is nothing but what? Regulatory element. So for your better understanding, let me present it on the board. Is it clear? So here let us we assume it has the 5' end, and here it is nothing but the 3' end. In the same way, here it is nothing but the 3' end, and it is nothing but the 5' end. So within the double-stranded genomic sequence, there is an availability of core promoter, is it clear? And the other component, it is nothing but what? Regulatory element. Regulatory element. Is it okay for you? So within the core promoter, there is an availability of different components. So what are the different components of the core promoter? The specific core promoter, likewise the prokaryotic promoter, it possesses or it consists of a specific constant sequence, and that specific constant sequence which is a part of the core promoter, it is nothing but what? Tata element. Is it clear? So what it is? Tata element. So let me write it here. In addition to the Tata element, very nearer to the Tata element, there is an availability of initiator element. So simply termed as INR. And here at the downstream of the promoter region, there is an availability of downstream promoter element. So simply termed as DPE. Is it okay for you? So here, what is the role of Tata element? The specific RNA polymerase enzyme, it is capable to bind to the promoter region by taking the advantage of Tata element. And here, once when the specific RNA polymerase enzyme, when it successfully recruits to the promoter region, the very first RNTP which is incorporated by the RNA polymerase enzyme, the specific site where exactly the RNA polymerase enzyme, it incorporates the RNTP, it is termed as what? Initiator element. So here the specific initiator element, it is quite homologous to the transcription start site in case of prokaryotes. Is it clear? And at the extreme downstream of the specific promoter region, there is an availability of a specific element, and that specific element, it is nothing but what? Downstream promoter element. So it is simply termed as DPE. So this is regarding the core promoter. In addition to the core promoter, very adjacent to the core promoter, the specific eukaryotic promoter, it consists of a specific component, and it is nothing but what? Regulatory element. So likewise the core promoter, the specific regulatory element, it possesses or it consists of different elements. So what are the different components of the regulatory element? So here the specific regulatory element, it possesses or it consists of upstream activating sequences. Is it clear? The specific regulatory element, it possesses or it consists of different components like upstream activating sequences followed by insulator, and very adjacent to the insulator there is an availability of repressor element, and very adjacent to the repressor element here there is an availability of promoter proximal element. So all these are the various components of the regulatory element. So for your better understanding, let me present it on the board. Is it okay? So what are those? Upstream activating sequences. Upstream activating sequences. And it also consists of insulator, repressor element, is it clear? And the other component, it is nothing but what? Promoter proximal element. Promoter proximal element. Is it clear? So all these are the various components of the regulatory element here. So here you may get a small clarification. What is the role of all these components which is a part of the regulatory element? So likewise the core promoter, the specific transcription mechanism or the transcription process, it takes the advantage of the various components of the regulatory element. So in order to regulate the gene expression, the specific transcription mechanism or the transcription process, it takes the advantage of two different elements, and they are nothing but what? Positive regulator, and the other one is negative regulator. So here the positive regulator, it is nothing but what? Activator, and the negative regulator, it is nothing but what? Repressor. So when the environment within the nucleus of a cell, when it is favorable in order to organize the gene expression, under such condition, the specific activator, it binds to the promoter proximal element. In the same way, when the environment within the nucleus of a cell, when it is not favorable in order to organize the gene expression, under such condition, the negative regulator, which is nothing but the repressor, it binds to the repressor element. Is it clear? So let me write it on the board. So what it is? Positive regulator. Positive regulator, which is nothing but activator. And the negative regulator, it is nothing but what? Repressor. Negative regulator, it is nothing but what? Repressor. Is it okay for you? So though the transcription mechanism or the transcription process in case of eukaryotes, though it is very similar to the transcription mechanism in case of prokaryotes, but still the transcription mechanism in case of eukaryotes, it remains vary from the transcription mechanism in case of prokaryotes in certain aspects. So what are the certain aspects here? In case of prokaryotes, in order to recruit to the promoter region, the RNA polymerase enzyme, the specific bacterial RNA polymerase enzyme, it takes the advantage of only one specific sigma factor. But whereas in case of eukaryotes, in order to recruit to the promoter region, the RNA polymerase 2, in case of eukaryotes, it takes the advantage of around 10 general transcription factors. Is it clear? And in addition, in case of prokaryotes, in order to organize the transcription mechanism, the specific mechanism or the specific process, it takes the advantage of only one specific bacterial RNA polymerase enzyme. But whereas in case of eukaryotes, the transcription mechanism or the transcription process, it takes the advantage of three different RNA polymerases. So what are the three different RNA polymerases in case of eukaryotes? RNA polymerase 1, RNA polymerase 2 and RNA polymerase 3. Is it clear? So these are the basic differences in between the prokaryotic transcription mechanism and as well as eukaryotic transcription mechanism. So here under in vitro conditions, under laboratory conditions, in case of eukaryotes, for organizing the transcription mechanism, the specific eukaryotic RNA polymerase 2, when it is in association with general transcription factor, under such condition, it is capable to organize the transcription mechanism. But under in vivo conditions, That means within the nucleus of a cell, the specific DNA which acts as a template for organizing the transcription mechanism, it is not available in a free form. Is it clear? So for your better understanding, let me explain it on the board. So let me arrange the things first. So under in vivo conditions, the specific DNA which is responsible for organizing the transcription mechanism, or the specific DNA which acts as a template for organizing the transcription mechanism, it is not available in a free form. The specific DNA, it is packaged within the chromosome. Is it clear? So let us assume it as the chromosome, right? So within the chromosome, the genetic material is packaged here. So here the specific DNA itself, it is not packaged within the chromosome. In order to incorporate into the chromosome, the specific DNA, it wraps around the histone octamer. So once when the specific DNA, when it wraps around the histone octamer, under such condition, it leads to the formation of nucleosome. So after wrapping around the histone octamer, the specific DNA, it is packaged within the chromosome. So here, in order to unwrap around the histone octamer, is it clear? So let me show it here. So here it is nothing but what? Histone octamer, right? So these are nothing but the histone proteins. So here the DNA is wrapped around the histone octamer. So here, in order to unwrap the DNA around the histone octamer, the eukaryotic transcription mechanism or the eukaryotic transcription process, in addition to the RNA polymerase II and the general transcription factors, it takes the advantage of certain chromatin modifying enzymes and nucleosome modifying enzymes. Is it clear? So by taking the advantage of chromatin modifying enzymes and nucleosome modifying enzymes, the DNA which is wrapped around the histone octamer, it successfully unwraps from the histone octamer. So once when the specific DNA, when it successfully unwraps from the histone octamer, under such condition, the specific DNA, it acts as a template for organizing the transcription mechanism or the transcription process in case of eukaryotes so accurately. Is it clear? So let me write it on the board. Under in vitro conditions, RNA polymerase II and in addition general transcription factors, they are required for organizing the transcription mechanism. But under in vivo conditions, the transcription mechanism, it takes the advantage of RNA polymerase II and in addition general transcription factors, and in addition it takes the advantage of chromatin modifying enzymes and as well as nucleosome modifying enzymes. So let me write it here. Nucleosome modifying enzymes. So by taking the advantage of these enzymes, the specific DNA which wraps around the histone octamer, it successfully unwraps, and the specific DNA, it acts as a template for organizing the transcription mechanism or the transcription process in case of eukaryotes. So this is regarding the promoter region in case of eukaryotes. So here at the very beginning of the initiation phase of the transcription mechanism in case of eukaryotes, the specific mechanism or the specific process, in order to recognize the promoter region, it takes the advantage of a specific general transcription factor, and that specific general transcription factor, it is nothing but what? TF2D. Is it clear? So let me write it on the board. So here at the very beginning of the initiation phase of the transcription mechanism in case of eukaryotes, in order to recognize the Tata element which is a part of the eukaryotic promoter, the specific transcription mechanism, it takes the advantage of a specific general transcription factor, and that specific factor, it is nothing but what? TF2D. So here the TF2D, it possesses or it consists of a specific component, and that specific component, it is nothing but what? Tata binding protein. So by taking the advantage of Tata binding protein, the TF2D transcription factor, it is capable to recruit to the Tata element. Is it clear? So let me write it here. What it is? TF2D. TF2D. So here the TF2D transcription factor, it is capable to recognize the Tata element by taking the advantage of Tata binding protein. Is it clear? So after the successful recruitment of TF2D to the Tata element, in the very next step, the specific transcription mechanism or the transcription process, it takes the advantage of one more other transcription factor, and that specific transcription factor, it is nothing but what? TF2A. Is it clear? So what it is? TF2A. So what is the role of TF2A? The specific TF2A, it is the transcription factor which is responsible for inducing the stability in between the Tata binding protein of the TF2D transcription factor and the Tata element. In the presence of TF2A, the specific TF2A, it induces stability in between the Tata binding protein of the TF2D transcription factor and as well as Tata element. Is it clear? So let me write it here. So let me use some other color here. What it is? TF2A. So after the successful recruitment of TF2A, the specific TF2A, it induces the stability in between the Tata binding protein of the TF2D and as well as the Tata element. So after the successful recruitment of TF2A, in the very next step of the transcription mechanism in case of eukaryotes, the specific mechanism or the specific process, it takes the advantage of one more other factor, and that specific factor, it is nothing but what? TF2B. Is it clear? So let me write it here. What it is? TF2B. So what is TF2B? TF2B, it is the transcription factor which acts as a mediator. For the successful recruitment of RNA polymerase II to the promoter region, a specific transcription factor is required, and that specific transcription factor, it is nothing but what? TF2F. So for the successful recruitment of TF2F, the transcription mechanism, it takes the advantage of a mediator, and that specific mediator, it is nothing but what? TF2B. So in the presence of TF2B, that means the TF2B transcription factor, it acts as a monitor for the successful recruitment of the RNA polymerase II by the TF2F. Is it clear? So in the presence of TF2B, one more other factor, it comes into the picture, and that specific factor, it is nothing but what? TF2F. The specific TF2F, it plays a prominent role for the successful recruitment of the RNA polymerase II to the promoter region. Is it clear? So let me write it here. What it is? TF2F. So here it is nothing but the RNA polymerase II. RNA polymerase II. And here there is an availability of a specific factor. It is nothing but what? TF2F. So in the presence of TF2F, the RNA polymerase II, it successfully recruits to the Tata element which is a part of the eukaryotic promoter. Is it clear? So let me write it here. So let me erase the things first. So here it is nothing but what? RNA polymerase II. So let me write it here. What it is? RNA polymerase II. The specific RNA polymerase II, by taking the advantage of a specific factor which is nothing but what? TF2F. Is it okay? So by taking the advantage of TF2F, the RNA polymerase 2, it successfully recruits to the promoter region. So once when the RNA polymerase 2, when it successfully recruits to the promoter region by taking the advantage of TF2F, under such condition, it leads to the formation of a specific complex, and that specific complex, it is nothing but what? Closed complex. Is it clear? So let me write it here. What it is? Closed complex. So after the successful formation of closed complex, in the very next step of the initiation phase of the transcription mechanism, the specific mechanism or the specific process, it takes the advantage of one more other general transcription factor, and that specific factor, it is nothing but what? TF2E. Is it clear? The specific TF2E, it is a dimer, that means it possesses two different domains. So here the specific TF2E, likewise the TF2B, it acts as a mediator. So for the successful recruitment of TF2H, the specific transcription mechanism or the transcription process, it takes the advantage of a mediator, and it is nothing but what? TF2E. So in the presence of TF2E, a specific transcription factor termed as TF2H, it comes into the picture. Is it clear? So let me write it on the board. So what it is? TF2E. So here in the presence of TF2E, one more other factor, it comes into the picture, and it is nothing but what? TF2H. So here likewise the TF2E, the specific TF2H, it is a dimer. It possesses or it consists of two different domains. So what are the two different domains which is a part of TF2H here? The specific TF2H, it consists of two different domains, and these domains, they are nothing but what? One is ATPase domain and the other one is kinase domain. Is it clear? So let me write it on the board. So what it is? One is ATPase domain and the other one is kinase domain. So here the RNA polymerase 2, which successfully recruits to the promoter region, it possesses or it consists of a specific domain at the C terminus, and it is nothing but what? Alpha C terminal domain. So here it is nothing but what? Alpha C terminal domain. Alpha C terminal domain. So here in the presence of TF2E, the specific TF2H, it successfully recruits to the promoter region. So let us assume it as the TF2H. Is it clear? So here the TF2H, it acts as an helicase enzyme. So in case of the prokaryotic transcription mechanism, in order to unwind the double-stranded genomic sequence, the RNA polymerase enzyme, it won't take the advantage of any factor. So without taking the advantage of any factor, in case of prokaryotes, the bacterial RNA polymerase enzyme, it is capable to unwind the double-stranded genomic sequence, so that the closed complex, it successfully converts into open complex in case of prokaryotes. But whereas in case of eukaryotes, the scenario is quite opposite. In order to unwind the double-stranded genomic sequence, the specific transcription mechanism, it takes the advantage of an helicase enzyme. And that specific helicase enzyme, it is nothing but what? TF2H. So by taking the advantage of TF2H, the transcription mechanism or the transcription process, it is capable to unwind the double-stranded genomic sequence, so that the closed complex, it successfully converts into open complex. Is it clear? So here in order to unwind the double-stranded genomic sequence, the specific TF2H, it takes the advantage of ATP. So here the ATP, it is induced or it is provided by the ATPase domain. As I have already mentioned you, the specific TF2H, basically it consists of two different domains. And these domains, they are nothing but what? ATPase domain and the other one is kinase domain. So here the ATP, it is induced by ATPase domain. Is it clear? In the presence of ATPase domain, the specific TF2H, it is capable to unwind the double-stranded genomic sequence, so that the closed complex, it successfully converts into open complex. Is it clear? So let me write it here. So let me erase the things first. Closed complex, it successfully converts into open complex. Open complex, right? So let me print it here. So like this. So let us assume like that. So here, once when the closed complex, when it successfully converts into open complex in the presence of TF2H, in the very next step, as I have already mentioned you, the RNA polymerase 2, it possesses or it consists of a specific tail, and it is nothing but what? Alpha C-terminal domain. So here the alpha C-terminal domain, which is a part of the RNA polymerase 2, it possesses or it consists of a heptad repeat sequence. In case of humans, there is an availability of a 52 heptad repeated sequence. So here the specific heptad repeat sequence, it is nothing but what? TSP and TSPS. Is it clear? So let me write it here. What it is? TSP, TSPS. The specific alpha C-terminal domain, it possesses an heptad repeat sequence, and it is nothing but what? TSP, TSPS. That means it possesses or it consists of tyrosine, serine, proline, tyrosine, serine, proline, serine. So here the serine amino acid, which is present at the second position of the heptad repeat sequence, it acts as a hotspot for the successful binding of TF2H. As I have already mentioned you earlier, the specific TF2H, it possesses or it consists of a kinase domain. So once when the specific kinase domain, which is a part of the TF2H, when it successfully binds to the serine amino acid, which is a part of the heptad repeat sequence, under such condition, the alpha C-terminal domain, it is capable to induce the synthesis of certain elongation factors. So these elongation factors, they are responsible for organizing the elongation phase of the transcription mechanism in case of eukaryotes. So once when the closed complex, when it successfully converts into open complex, and once when the RNA polymerase enzyme, when it is capable to induce the synthesis of certain elongation factors. So synthesis of elongation factors by the RNA polymerase 2 in the presence of TF2H, it indirectly suggests or it indirectly says that the initiation phase of the transcription mechanism in case of eukaryotes, it is successfully organized. So once when the initiation phase of the transcription mechanism in case of eukaryotes, when it is successfully organized, within no time the elongation phase of the transcription mechanism, it comes into the picture. So which we are going to study, which we are going to learn in the next upcoming video session. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.